Hello there. Welcome back. This is chapter 1, part 3, and we are beginning with slide 24. Okay. So now what we're doing is we're looking at ratios, and we're looking at ratios and how they work in proportions. And that's a lot of what we're going to be doing up in there. So the example that you can see here shows a couple of different ways to show ratios. And the first one is showing a price ratio, showing, say, 5 pounds of something sold for 4.45, and that gives you 89 cents per pound. And then you can also flip the ratio over and say 5 pounds for $4.45, which gives you 1.1 pound of whatever you're purchasing per dollar purchased. So you can always show a ratio in one way or another. Okay, so let's take a look at the example that we have here, saying that suppose your supermarket is offering a 20-count shrimp, so that's one part, for $5.99. Oh, you know what? This shouldn't be per pound. So take this out. Okay. It's offering 20-count shrimp for $5.99. All right. So how much should you expect to pay for 1 dozen shrimp? Okay. So basically what we're doing here is that this 1 dozen here, it becomes your given. Okay. So that means that I have 12 shrimp like this. All right. And now I set up the same thing I did before. If I have 20 shrimp, I will pay $5.99. All right. And this tell me how much I'm going to pay for 12 shrimp. So you might say, okay, how do I put that into my calculator? You're going to say 12 times 5.99 divided by 20. Okay. And that on your calculator is going to give you 3.594. But it's money, right? And so money is always going to be recorded in a specific way. Okay. And so we've got 3.594. We can't have that 4. 4 rounds down because it's less than 5. So the answer that we would report would be $3.59. It's one way to do this ratio work. It's also called dimensional analysis. So let's take a look at some more information with ratios in chemistry. All right, we are on slide 25 now. Okay, so first we're going to look at mass density. And mass density is a ratio of an object's mass to its volume. It's always temperature and compound specific. Density changes based on the temperature of the object. It can expand or contract based on temperature changes. Okay, but it allows the conversion between a mass and a volume. Now, sometimes students don't like solving for other things. So you could say that if density is equal to mass divided by volume, that mass is equal to density times volume. And we can find volume equal to mass divided by density. Okay, so let's take a look at this first problem here. So it tells us that we have the density of water at 25 degrees C. We can ignore that value. It's not going to be put in here, is 0.997 grams per mil. Okay, so that means that density is equal to 0.997 grams per milliliter. Okay, just as a rewrite. Now, a child's swimming pool holds 346 liters of water. What is the mass of water in this pool? Okay, well, first of all, take a look at what we've got here. So see how this is our volume, and see how the volume is in liters, but the density is in milliliters? Okay, so we need those two things to agree. So our step one here is to convert our volume so that our units will agree. And so we say, okay, I have 346 liters. And from those conversion sheets before, we know that there's 1,000 milliliters in 1 liter. So we have 346 times 1,000, or 346,000 milliliters. Now the units agree for my volume. All right. So now our second step here, our step two, is going to be to solve for mass. So you note here that it says what mass, so that's how we know what we're solving for. Okay. And we're going to use this middle one here to solve for mass. So we see that mass equals our density times our volume. Okay. And so that means that we have 0.997 times 346,000. And this is grams per milliliter. And this is milliliters. And then we're just going to be left with grams. Now, when we do this math, what we're going to get is 344,962. And our units will be grams. But see how we have 1, 2, 3 significant figures here and 1, 2, 3 significant figures here. That means that we can only have 1, 2, 3 significant figures in our final answer, which gives us 345,000 grams. Okay. All right. And you can report that as 345,000 grams. We could report that as 345 kilograms. Both are valid. Okay, right here. You could even, if you wanted to, report that as 3.45 times 10 to the 5th grams as well. All three of those answers are fine because we haven't specified our units. Okay. But you do have to include units so that I know what you're looking at. All right, let's take another look. Okay. Part 3 will be nice and short. Okay, so now we have a density calculation, and this is slide 26. Okay, it says, what is the density of a cube that is 0.65 centimeters per side with a mass of 1.2 grams? Yeah, and if you can't see everything on the slide, it is all in your notes template, which hopefully you are filling out with lots of neat and tidy math. Okay, so we look at this. Step one here is to first determine the volume of the cube. Okay, so we can see here that we have a cube. I like drawing pictures. And it is 0.65 and 0.65 and 0.65 centimeters. Okay. This would be a good time. I can't remember if we said this before, but let's take a little bit of a step here, and we're going to introduce something here at the top. Okay. So first of all, solids are reported in either grams per centimeter cubed, okay, or kilograms per meter cubed. Pay attention to what you're doing with this because they'll be different. It's not exactly the same. Liquids are reported as grams per milliliter, and gases are reported as grams per liter. Now, the important thing to remember here is that a cubic centimeter is exactly the same as a milliliter. So sometimes you'll need that going forward, okay? Make sure you have those. Okay, now we'll go back to our calculation here. Okay, and so the volume is length times width times height for any rectangular solid. So in this case, we have 0.65 times 0.65 times 0.65. Okay. And the value of this, again, you should be working through this on your calculator too, so that you're making sure that you're getting the right values, is 0.274625. But this is, again, we need to stop for a second. We need to find our significant figures. So here we have 1, 2 significant figures, which means we can only have 2 significant figures in our answer. And that gives us 0.27 cubic centimeters. Oh, now let's take a look at our step 2. Step 2 says calculate density. Great. So density, remember, is equal to mass over volume. And here we have 1.2 grams for our mass and 0.27 cubic centimeters. And when we put those together, we get 4.4, etc., repeating. Now we can only have, again, we have 2 significant figures here and 2 significant figures here. So we can only have 2 significant figures in our answer. 4 is less than 5, so this rounds down to 4.4, and make sure you include your units of grams per cubic centimeter. All right, now we have a challenge problem, and this is great for getting us ready for our homework. And our final slide, and this is slide 27. And our final slide, this is going to be a short part. It says calculate the density of the Earth in grams per centimeter cubed from a diameter of 7,926 miles. And here you have the conversion from kilometers to miles, and a mass of 1.317 times 10 to the 25th pounds, where 1 pound is equal to 0.4536 kilograms. Okay, so real quick, let's just isolate a few things here. Here we have 1, 2, 3, 4 significant figures, and 1, 2, 3, 4 significant figures. Oh, look, this has been set up so nicely for us. And 4 significant figures here, and 4 significant figures here, and everything is 4, which means our final answer is going to have 4 significant figures. So we're going to think that through. Okay, our first step, we'll say step 1, is we need to convert pounds to kilograms to grams, because notice that I need my mass in grams. So I start with the value I have here, 1.317 times 10 to the 25th pounds. Okay. And now I use my conversion here that 1 pound is 0.4536 kilograms. Okay. But I need to go all the way to grams. So I know from before that every kilogram has 1,000 grams. Right? And I work through this and I get 5.973912 times 10 to the 27th. And I can have 4 significant figures, so this becomes 5.974 times 10 to the 27th, and it's in grams. Okay, so this is my mass. All right, step 2 is going to be, let's see, step 2 is to convert our diameter Okay. From kilometers to meters. Oh, sorry, hang on. I can't go to kilometers just yet. Is to go from miles to kilometers to meters to centimeters, because that's what I have. Okay. So let's look at how this is done. So I have 7,926 miles times, okay, here I have every 1 mile will have 1.609 kilometers, and every kilometer will have 1,000 meters, and every meter has 100 centimeters. And if you're not sure where I got those so fast, they come from our conversion papers before. 1.609 kilometers would be a value that you were given, or it's a value that is also on your conversions page. Okay, so next, when I look at this, the value that I get here is 1.2752934 times 10 to the 9th. And I can only have 4 significant figures, so this becomes 1.275 times 10 to the 9th. And that is in centimeters. Okay. Now okay, so we have 1.2. Now our next step here, okay, is that we need to find volume. Okay, now remember, and this is also on your conversions page, but the volume of a sphere is equal to 4/3 pi r cubed. So I need to find the radius. Remember that a radius is half of the diameter. Okay, so it might have been easier if I'd have done that first, but I can do it now. Okay, and so what I do is I divide my diameter by 2 to get a radius of, so 1.275 times 10 to the 9th divided by 2 gives me a radius of 6.375 times 10 to the 8th centimeters. So I find this, I have 4/3 times pi times 6.375 times 10 to the 8th cubed. Okay. And again, pause this and practice it on your calculator to make sure that you are getting the same value. Again, we can only have 4 significant figures. So this becomes 1.08, whoops, 8, 1.085 times 10 to the 27th cubic centimeters. And that is our volume. Okay, so here we have our mass. And here we have our volume. And last, we can find our density. So our step 4 is to calculate our density equal to mass over volume. And I've already made sure that my units are what I'm looking for. It's very important to do that first. And I have 5.974 times 10 to the 27 grams divided by 1.085 times 10 to the 27, and that's cubic centimeters. Okay. Now, when we work through this, you will get a value that is 5 point, whoop, again, there we go. 5.506 times 10, no, times 10. 5.50, and I don't want to give you that 6 yet either. getting ahead of myself. Okay, I have 5.505990783. There, that's what my calculator is giving me. I can only have 4 significant figures, so that becomes 5.506, and my units are in grams per centimeter cubed. And that is my final answer to this problem. All right. Well done, everybody. That concludes part 3 and the last of our lecture videos. Fill in your notes template and you should be ready to begin your homework. I'll see you in class.